And I have properties here. Some I think I mentioned last time, but you want to make sure you memorize these. You can put them on an index card. You can't have the index card for a test, but it will help you to memorize them. These are the ones I think we had before, down to this point. This third one, I haven't seen that used in the Myopenmath software. It is a standard one, and same thing here. So when you are raising from a power, so it's an exponential, but if the bases are the same, the answer is just whatever you're taking the log of up here. Same thing on natural log. If you're raising from the base of e and it's ln, then that is also base of e. They're the same, so it's x. So I'm going to go ahead and leave those in the list because they are standard properties. The ones we really concentrate on today are the last three, and we will use these to expand logs and then to condense them, put them back together. So our first one is the log of a product. So things are multiplied. You can expand that into the log of the sum, or sum of the logs, sorry. It expands and makes as many logs as you have pieces here. So, and it keeps the same base, and it's sum. When it is a quotient, so it's a fraction, it will be subtract, and it will make as many as you have pieces here. If you have an exponent, the exponent will come down, out in front, and be multiplied. Not sure what I did there. Except move my home page too close to the edge. Right, so we'll do some problems, and I'll make sure that you get that page. So first problem, these first ones are going to use the product, right? And so the key word here is expand. Use the properties of logarithms to expand. And our first one we're going to use is the log of a product of m and n is equal to the sum of the separate logs. So question 1 says the log base 5 of 4 times 6, and they want us to expand it. So this is a product. So it will be log base 5 of 4 plus log base 5 of 6. And you have to look at these and see if you can simplify. You're not going to be able to simplify this one. You can't write 4 in terms of 5 to a power, and you can't write 6 in terms of 5 to a power. So that is going to be our answer. A lot of times I write this without the parentheses if there's not more pieces here. Let's just do that real quick and see if we can get away with it in the answer box. So if we write, we want functions, and we want the log with a box because we have a base 5, and then we want out of that box, so it will be 4, and it does the parentheses automatically here. All right. And then I'm using the arrow button to get out of there, or you could use your mouse. And we'll see if it fusses. It just filled in for me, so you should be okay there. Right. Then I skip to question 3. So we have log base 2 of 8t, and this is a product, so we're going to write it as the sum of those two logs, so we'll write log 2 times. And you have to check and see. This one you can write 8 as 2 to a power. So you can rewrite this as 2 to the third, and you just play on your calculator till you get it, if it will. And so this simplifies to 3. These are the same. The answer is the exponent. This one, there's nothing you can do, so you're going to just leave that. It's log base 2 of t. Stop me if you have any questions, okay? So I did pick question 4. And this one is log, and it's base 10 of 1, 2, 3, 4 zeros. And they still want us to expand. And so it will be a sum of the logs. And this one is 10 to a power. It is 10 to the fourth. Just verify that real fast. And I can verify that with my calculator because I can work base 10. So log of 10,000 is 4. Okay. But they wanted me to write it this way. And this is base 10. So my answer is going to be 4 plus the log base 10 of u. And we should be good there. All right, question 5. We go to the next one, next property to expand with. And this is if you have a quotient. So let's rewrite it. So if we're going to do the log of a quotient, then we're going to subtract the logs. So we'll make separate logs and subtract them. So here we have natural log of e to the fourth over u would be ln e to the fourth minus ln of u. And this one, remember this is base e. These are the same. The answer here is the exponent. So that one will simplify. This one will not. So 4 minus the ln of u. And 6 is going to be a nice standard problem, just plugging in. But we'll do it to have another one on here. So log base 2 of t over 15 equals log base 2 of t minus log base 2 of 15. And there's nothing else you can do. You can't rewrite t in terms of 2 to a power or 15. So that should be our answer. And 7 just brings in an extra piece. When you have more pieces in this quotient, anything that is on the numerator is going to get a plus in front. Anything that's on the denominator is going to get a minus in front. And sometimes you might have a product down here. It still will work out that way. You could put a minus and you could do separate steps and distribute it. But you can also go with that little shortcut. If it's on the numerator, it's going to get plus in front when you break it apart. If it's on the denominator, it will get a minus in front. So we have the log of 9x over 5 is equal to the log of 9 plus the log of x minus the log of 5. And these are all base 10. And nothing else we could do to those. Question 8 will have a piece that will simplify, so we'll look at it. So log base 4 of 16 over u. I'm going to expand it, make 2 logs. So the log base 4 of 16 minus log base 4 of u. You can rewrite 16 as 4 to a power. It is 4 squared, which makes these the same. And your answer from one of our properties will be the exponent. This one, there's nothing you can do to. So it will remain as log base 4 of u. Nine brings in our next property. And this is if you have an exponent there, it will come down in front of the log. So I'll rewrite that property. So if you have the log of m to the p will come down and it will give us p times the log base b of m. So that's what we're going to use on question 9. So we have the log base 14 of y to the 12th. The 12 will come down. So we'll have 12 times the log base 14 of y. On 10, you need to remember if it has a radical, that is a rational exponent, so a fractional exponent. I think we can fit it here. So we're going to write this one as subtract because it's a quotient, but I'm also going to rewrite that radical as u to the 1/4. So I have log base 7 of u to the 1/4 minus log base 7 of 49. So I can do a little work on both of those. The 4th will come down with our newest property. We'll have 1/4 the log base 7 of u minus, this one you can rewrite 49 as 7 squared. And then these are the same, so the answer to that piece is 2. So that would be our final answer. So good there. I skipped 11. It's an easy one. And we'll go to 12. So we have the log base 3. And this one has a few pieces. Right, so if they're on the numerator, they're going to get a plus in front when we expand it. If they're on the denominator, they're going to get a minus in front, and this will be a fractional exponent to this whole thing. So we're going to have 3 logs right? And to completely expand it, we have to take the exponents down. So they're all going to come down. So we'll have 9 is the log base 3 of y plus 6 times the log base 3 of z minus 1/5 times the log base 3 of x plus 8. So looks good. There's our answer. And really, you learn how to do these. We're going to condense in a few minutes. The part you really use is condensing. And you do that so that you can solve equations. So I guess you learn this so you can learn to go backwards. Put it back together. All right, and this one looks a little scary, so we'll do it. So we have natural log of x to the 6th times this radical. So what you really have here is a product of these two pieces. This is an 8. So remember, the product is the sum. So we'll start with that. Natural log of x to the 6th plus natural log of this whole piece. And we can go ahead and write this to the 1/2. And I didn't realize it before, but I could have cleaned that up there. That's all right. I'm going to go ahead and do it the way that I did earlier. So we'll take the exponents down. So we'll have 6 times the ln of x plus 1/2 times the ln. And this we're going to end up separating because this will be subtract. So let's go ahead and just do that, and we'll use parentheses. So we're going to do the ln of y to the 14th minus the ln of c to the 8th. And I didn't really need that parentheses here. All right. So let's take this one off too. Where I did need them was here. And just the big one, because the half goes to both of them, right? And I'm going to actually just distribute that. because then you're going to take these down, and so it's going to multiply that. So you're going to have a half times 14, which gives you 7. And this one will be 8 times a half, which will give you 4. And that should be our final answer. So you had to work on this a little bit. You could have left your radical on here, and just eventually, though, that whole thing was under the radical, so that half, watch out, it will apply to both pieces when you split it up. And let's just make sure I have it. And I'm getting sloppy and leaving these little parentheses off, but I think we'd be okay there. So now we're going to switch and condense them. And anytime it says condense, they want you to put them back and make only one log. So condense is your key word. And this part is really important because when you do equations, if you have a sum of logs or a difference of logs, you want to put it together and make one log before you can solve. So, and it won't say condense, you'll have to know to do that. So this is actually a skill that you will use. And so we'll go ahead and do 14. So what we have is a sum of logs. Log base 20. And so sum of logs comes from log of a product. So that's what we're going back to. So you write log one time with that same base. And you can go ahead and multiply that out since those are numbers. Log base 20 of 400. And you have to just check, is 400 a power of 20? And it is. It is 20 squared. So the log base 20 of 20 squared. And so the base is the same as what you're taking the log of. The answer is 2 on this one. So 15. We are also going to condense. So log base 2 of 64 minus log base 2 of 8. This one is subtract, so it is going to be a quotient. So log base 2 of 64 divided by 8. And it's okay to go ahead and do the math here. Actually, that is what you need to do. So 8 will go into 64 8 times. So this gives us log base 2 of 8. And this we can simplify because 8 is 2 to the third. These are the same. Answer is the exponent. If you have things to condense, if you have several terms, you always put the exponent back on first. This one only has one, but you deal with the exponent first. So this number out in front will be the exponent, and I think they want you to put it back as a radical if it's a fractional exponent. So we have log base 4 of s to the 1/7, which they would like us to write as a radical, which is the 7th root of s. You doing okay? All right, good. Just let me know if there's anything you have a question on. All right, we'll do 17 because it gives you a few pieces. And you would always want to look first and see if you're going to get a fraction. You're going to get a fraction because it has a minus in it. So we'll write it. So we have 4 natural log of z plus 5 natural log of y minus 10 natural log of w. So exponents will go back on first. So this will be natural log of z to the 4th, natural log of y to the 5th, minus natural log of w to the 10th. Right now we'll write natural log one time. This minus is going to make us have a fraction, and z to the 4th and y to the 5th will go on top as a product because you have plus here. W to the 10th will go in the denominator, and that should be our answer. Now we have only one log. Right, 18. This one we have 2 times the log base 5 of 5 plus log base 5 of a minus the log base 5 of 2. Right, and so this 2 is going to apply to both of these and go back as an exponent. So you could distribute it. Might be clearer if you did that. Let's just do that. So 2 log 5 of 5, which that would also simplify. I think it's probably easier if you don't. Just leave it there. Right, and this one we didn't do anything to. All right, so now put your exponents back on. So this goes on this one, and this will go here. So we're going to have log written only one time. This will be 5 squared. I went ahead and worked that out and put 25. And this will be a squared. Those go in the numerator. This is after the minus, so it will go in the denominator. And that's what I had for the answer, which I think it will take. I believe on their answer, they had left the 5a squared over 2, like that. I'm going to try to enter it the first way, because I think that is also acceptable. So, this one, base 5, and we'll come out of that. We want a fraction here. And that was not what I wanted. So we'll start over and do this. So we have the log base 5. Come out of that, and I'll put the parentheses. And I'm going to enter the fraction. I'm going to put the 25. And this was a 2. And so they're fine with that. In their key, they did not. They just put the 5a and then it was going to be squared. So this piece. So you could have put this part together first. The 2 logs on the inside could have gone together as a product, the 5a, and then put the exponent of 2 back. So there's different orders you could work there and get the same answer. Right. I skipped then to number 20. And this one would simplify, but they wanted us to condense, so we'll just leave it. So they want us to make 1 log. Right now it's a sum, and that's probably why I did this one, because I thought you should just simplify it first. So the log 3 of 3 times 9, which is 27. And I think that's the answer they wanted. This would simplify, and it's because both of these would have simplified. This is 1 right away, so a different way, right? And this would simplify. So this is the answer they wanted, but we could have simplified at the beginning. So log base 3 of 3 is 1, and log base 3 of 9 is 3 squared. So log base 3 of 3 squared is going to be 2. The answer is 3. You could get the same thing here. Log base 3, 27 is 3 to the 3rd. These are the same. The answer is 3. So let's type in a 3 and see if they fuss about that. And they did. So even though it would simplify, I don't know. It says where possible, evaluate logarithm functions. There may be an error on that problem. Let me make a note, because I would say just the 3 would be good, but they didn't like that. And it was log 3 of 27 that they wanted. So when you do your work, leave it as log 3 of 27, but I'm going to check on that with our person that programs this stuff. Right. And I skipped then to 22. This one is a piece of cake. The 16 just goes back up. And this one, you're just going to put the exponents back on, and then it's going to be a product because it's plus here. So put the exponents back. And then write log 1 time will be w to the 5th, x to the 6th. And there we go. 23 I skipped. 24 I picked just because of that different looking base. I didn't want it to worry you. Right, so it is a sum of logs. We don't have any exponents, so it should be the log of a product which would be x times x minus 8. I don't know if it would take that answer or not. You could leave the dot out. I think it wanted you to multiply, but we'll check it. So if we do need to multiply, it would be this. So let's enter it log. Whoops, that's not the log I want because that one would be base 10. I need the log with the box underneath. And in that underneath spot, I need to put a fraction. So 4 and 3. And so I did the out arrow. I did my keyboard. You could also use it here. I didn't realize they had them here. And then go up and up again. And I'm going to enter it without multiplying. So I'll put the parentheses. I'm just doing this to see if it, okay, it didn't like my parentheses. X times x minus 8. And you would need a second parenthesis. So we'll see if it accepts that answer. And it did not want that. It wants me to multiply it out. So x squared minus 8x. So multiply that out. It's equivalent, but we won't argue with them. Oh no, I thought I wrote that. Maybe I did, and then I erased it or something. So I'll put the answer back on here. All right, and 25 we switch gears and we have a different kind of question. This is a change of base question. And for the older calculators, which is actually like what I have and that I have a template for, the TI-83 Plus, you are not able to evaluate logs of different bases. So you want to be able to change to other bases. The TI-84 Plus, it actually has a button where, excuse me, you can do any log and evaluate it. Also, where that's even more useful is graphing. So, we'll go ahead and just work with the calculator I have because I don't have a way to show you the other one. And then I might make a video later. I can do the old program I had without using this tablet, and then I could just show it on my desktop. All right, so we're going to convert. I don't usually memorize the formula that is given because it puts so many letters on it, it's hard to remember, right? These questions, they don't all go to base 10 or base E. The first one does. So when you're going to go to base 10, which that's a good one to choose because it's on your calculator, right? So then I just take the log of whatever is higher up, not bigger, but higher in position. That will go on the numerator. And this one will go with the log on the denominator. Same base here. We used base 10 because that's what the question said. Switch from base 8 to base 10. If it tells you to go to a different base, you could just put that base on here. So the base that you want goes here. Whichever one is higher up goes on top. Whichever one is down low goes on the bottom. All right, and then they ask us to work this out. So this is where you would put pull up a calculator. So we're going to do the log of 10 divided by, and you do want to close that parentheses, the log of 8, close and enter. So you get a decimal, 1.10730, and they say to round to 4 places, so you needed 5. A 0 is not going to push you up. So 1.1073. Oh, and they want it in 2 steps. So they want this, and then there's your answer worked out. The next one is going to take us more steps. Right, so we're going to convert log base 2 of 5 from base 2 to base 7. All right, so start with what you have, right? And we're going to make a fraction. Put the log of what you're taking the log of goes on the numerator. The log of the 2 goes on the denominator. And we want base 7, so we will just put 7 on there. Now, this is not going to evaluate in my calculator. This is what they want for the first answer. But to evaluate it, you need to change this to base 10 or base E, because that's what's in the calculator. So if we do this top one, if we change it to base 10, it would say, so we're going to make a complex fraction. We would do log 5, except now we're doing base 10 over log 7. And this one will be log of 2 over log of 7. And if you remember complex fractions, you can multiply on the top and the bottom by the common denominator. Well, your common denominator is log base 7. So this is going to clean up. I'm sorry, not log base 7, log of 7. It's log base 10. So we're multiplying by that. It's going to cancel these out. So now, to go in my calculator, I'm going to take the log of 5 over the log of 2. And I can evaluate those. So log of 5, close your parentheses, divided by log of 2, close the parentheses, and enter. So we get 2.3219, and you want 4 places, so a 2 is going to drop off. There we go. That one would be off. Right, so we have one more, and this one asks us to convert to base E. Base E is nice because it's in your calculator. So we'll say we're going to base E. So this is what we're starting with. And we'll write natural log, because that is always base E, of whichever one is higher goes on top. This one that's down low as the base goes on the denominator. And that is your first answer. And throw those parentheses on there. This can go straight to your calculator. So you will use the LN button for natural log. Whoops, it doesn't like my pen on there. Right, natural log of 4 divided by natural log of 13. You do have to put these parentheses, close them on that, otherwise it puts more in with that piece. And enter. into 4 places. This time the 7 is going to push us up. So 0.5405.